All right, hey, what's up again? Mr. Fortin here. So we got some fraction problems. These have been coming up all year, and you might be wondering, what the heck? We haven't had any lessons on this. What's this all about? I'm not sure, and that's fine. I mean, fraction problems are just known to be a hard thing. Like it's known to be something that people get tripped up on. People maybe give up on them, which is not the greatest thing. You want to get them, okay? So these are technically review problems from middle school. You should have you learned your fraction laws. Should have come in. Should you be perfect at these? No, not really, but you should try to practice them. Try to get as good as you can on them, okay? Because there are no new lessons in high school when it comes to fractions. You'll find yourself on more advanced homework a little bit later in algebra 2 and beyond, where fractions will come up and you'll be like, oh, I wish I kind of know those properties a little bit better. So that's why I'm going to go over it for you right now. Okay, a few things to keep in mind here is that when adding or subtracting, okay, so when adding or subtracting, convert to an improper fraction. Well, actually, you do that. I would recommend doing that on any of these problems here. Convert to an improper fraction. When improper fractions are kind of like this, that's something like 8 over 5, something like 60 over 7, 222 over 58. What I'm trying to show you here is that these are written as a mixed number. I can write this as an improper fraction. The way that you do that is that you have -8, and that's -8 over 1, right? Right? That's -8 over 8. -8 is just a number, right? It's an integer. Okay, -8 over 1. I want to change the mixed number -8 and 2/9. Okay, so the 2/9 is also negative, but -8 and 2/9. I want to change that to a fraction that has a denominator of 9. Okay, improper fractions they're not mixed numbers, so you don't see that number in front. You just see a numerator, you see a denominator. So the question is, how do I change -8 to a fraction with a denominator of 9? Well, -8 is the same thing as -8 over 1. Okay. If I want to get the denominator of 9 over there, I need to make my numerator. Remember, the denominator divides, right? -8 divided by 1 would equal -8. But what divided by 9 would equal -8? That's one way to think about it. A little bit messy here. Here's maybe one way, more mathematically, the way you can kind of do it. You can change to an improper fraction. You can take this -8 over 1. I want to change that to over 9. The reason why I do that is I want to combine that. I want to add in that -2 that's right here. Oh, this is tricky. I'm not a middle school teacher, so I have trouble describing what to do here for fractions. But the way you can get the -8 over getting it over 9, right? An equivalent way of writing -8, but with 9 as a denominator, is just simply to do this. Multiply it by 9 over 9, okay? You're allowed to do that because 9 divided by 9 would equal what? 9 divided by 9. What's anything divided by itself? It's 1, right? It's 1. So if I have -8 and I times it by 1, what does it equal? Well, -8 times 1 is just -8. -8 times 9 over 9, well, I can use my multiplication rules with fractions. -8 times by 9 would equal -72. It says numerators multiply. When I'm doing fractions, numerators multiply together and denominators multiply together. So this is -72 over 9, okay? That's what the -8 equals, okay? It equals -72 over 9, okay? Right? And that kind of makes sense. You can double check your answer right here. 72, make it negative, divided by 9, what do I get? I get -8 right there. So that's the same freaking thing. And -8 is just simply -72 over 9. It's an equivalent way of writing it. Okay, but it's this here. This mixed number isn't just -8. It's -8 and another 2/9, right? Another -2/9 here. That's, the negative goes all of it here. So how do I change this to an improper fraction? Well, I simply take away that one little fraction right here from the thing that I just converted, okay? So I get -75 over 9, okay? So that's how I do this problem. Change it to an improper fraction, -75 over 9, and then I change this one to an improper fraction. Then it's a little bit more you got to do here, finding the common denominator. I'll do that in a second, okay? But the idea is now I'm going to change this one to an improper fraction. So with this 7, I need to change this 7. Remember that 7 over 1, I need to change it to 7 over what to combine with this 3/5? I need to change it. I need to get it over 5 somehow, okay? So what I'm going to do is I'm going to multiply this by 5 over 5. Remember, 5 over 5 is just simply a way of writing the number 1. 7 times 1 would be 7, okay? But 7 times 5 is 35, and 5 times by 1 would be 5, okay? So 5 is just simply 35 divided by 5, isn't it? 35 divided by 5 is 7? Yeah, it is. Okay, so what I can do is 35 over 5, and then I'm going to add to that 3/5. Okay, I'm going to add because the sign in front is positive. Okay, so this is positive 7 and 3 more fifths. So positive 3 more fifths here. Okay, so I get 38 over 5. Okay, I get that. So step 1, convert to improper fraction. Might take some review, might take some practice, but I think you can get it. And then find the common denominator here. Okay, the common denominator is here. I want to combine these fractions somehow. I can't just add 75 parts to 38 parts here because this 75 parts is, negative 75 parts that is getting divided 9 ways. This 38 parts is getting divided 5 ways. So they're getting divided by different amounts. Okay, so I need to somehow find common denominator. Okay, find common denominator. Okay, denominator. And 9 and 5, like 5 doesn't go into 9, so 9 can't be the common denominator. The common denominator is basically you want to find the least common multiple. You want to find a number that both 5 and 9 both go into. 5 goes into 10 twice, goes into 15 3 times, but 9 doesn't go into either of those. Then 20, 9 doesn't go into that. 25, 5 will go into that, but 9 doesn't. 30, okay, so on and so forth here. What's the lowest number that both 9 and 5 go into? Oh, it's actually 45. Okay, it's 45, right? 45. So 9 times 5 is 45. That's going to be our common denominator. There's not a lower number than that both 9 and 5 go into. Okay, so anyways, we need to change it so we have a common denominator of 45. So this is what we're going to do. Negative 75 over 9. I'm going to do my same rule where I'm going to multiply it by 1. Okay, but I want to get my denominator up to 45 here, okay, because we're going to combine it with a denominator up to 45 here in a second. So it's just review from middle school. We don't have a new lesson on it. That is a hard process, so hopefully you're getting something. I'm just watching this here. But anyways, how do I get a denominator of 45? Well, I'm going to multiply this by 5 over 5, okay? The one number you're allowed to multiply to an expression without changing that expression is 1, okay? Why? Anything times by 1 is equal to itself, so it doesn't change the expression, okay? So I'm going to do that. And I'm going to do the same thing, or a very similar thing to 38 over 5. I'm going to multiply to it 9 over 9 instead. I'm going to multiply it by 1. Here, 5 times 9, what does that equal? It equals 45. I have a common denominator now. In a second, I will. And 38 times by 9, ooh, that's messy. That's why I have your trusty calculators out during class. You don't want to do that mentally in your head. You want to save your brain space for what to do in the problems, not just what the answer is here. So you're going to do 38 times by 9. Okay, we got 342. Okay, and then we have negative 75. So we got 75 times by 5. Okay, negative 375 over 45. And there it is. We got a common denominator, okay? Once you get the common denominator, you can actually add these together. I got negative 375. That's being broken up 45 times, being divided by 45. I got 342. That's being broken up. That's being divided by 45 times. So you know what? They're both being divided by 45. So that means, you know what? They got a common denominator. We can just add them. We can figure out in total what's being broken up by 345. What's being divided by 345. So, sorry, by 45. Okay, so I'm going to do negative 375. Okay, let's make that one negative. And we're going to add 342 to it. And I get negative 33 over 45. And is that actually the simplest I can write my answer right here? What do you notice? 33. There's a number that actually goes into 33. It also goes into 45. What number is that? 3, right? 3 goes into 3 11 times. So, I can simplify my fraction. If I can figure out a number that goes into both of these here, 3 goes into 33, right? We're going to 30 10 times, so 33 would be 11 times. So this is going to be negative 11 is going to be our numerator, okay? And then 3 goes into 45, and it does, right? Doesn't it? It goes into 45 15 times, okay? Well, you can do that in your head. If not, you can do it in a calculator. Okay, so my answer here is negative 11 over 15. I really hope I did that correctly so I don't have to refilm this video. Let's get my answer here. Oh, man, I made a mistake. Okay, what was my mistake here? Let's check it out here. Mr. Fortin, what did you do? 38 times by 9. Let's see, 20. I wasn't off by much. Sometimes when I'm explaining things, I'm not really thinking hard enough about the problem here. So where was my mistake? Did you find it already? Did you find it for me? 38. Wait, did I make a mistake here? Let's see. 38. No, that wouldn't be a mistake there. Did I go down further? It was the 2 here. It should be 74. Yeah, that was my mistake up top here. Okay, so check it out. My mistake here was when I changed this to negative 72 over 9. I needed to go back 2/9 more. I went back 3/9 more. So here, there's 74. 74 right there, okay? This changes the whole complexion of the problem because this got multiplied by 5 a little bit later. So let's just prove to you that I know my mistake. You might have trouble following here. So I'm going to do times by 5. Okay, that's negative 370 here instead of 375. Okay, negative 370 plus 342. Okay, that would equal negative 28. And there you have it, negative 28. Okay, 28, this actually can't be reduced now. So let's get rid of this entirely because 3 doesn't go into 28. 4 goes into 28. 7 goes into 28. 14 goes into 28. 2 goes into 28. But 14, 2, 7, 4, 28, 1. Oh, 1 goes into 45. None of those go into 45. So this is my simplified answer. We got our answer there. See, mistakes happen. It's all good. We get to the bottom. That's the nice thing about answer keys. You can check them afterwards, and then you can figure out what you did wrong, okay? All right, let's check this one out here. Let's do this one real quick here. It always goes, the first example is always the most slow, and then we can get some practice because I've already told you everything here, okay? All right, step 1, what am I doing? I need to get the 8 denominator right here. So what I'm kind of thinking of doing is this, negative 4 times by, well, 8/8, okay? What's negative 4 written in if it's being divided by 8, what would it have to have been before that, okay? So negative 4 times by 8, that's negative 32, okay, over 8. That's, 32 divided by 8 is 4, so that negative 32 divided by 8 would be negative 4. Okay, we got to move 3/8 further than that. Okay, so we'll do that in a second. We'll do the same thing with the negative 5. Oh, common denominator of 8. That's nice here, okay? So 5, okay, 5 times by 8/8, okay? 5 times by 8 would be 40, okay? So I'd do 40/8, and then we're subtracting the whole thing here. So maybe I'll do parentheses here, plus 3/8 to figure out how much I'm taking away afterwards here, okay? Negative 32 minus 3 is negative 35/8, okay? So negative 4 and 3/8 is equivalent to negative 35/8, okay? This is just written it as an improper fraction, okay? Now I'm going to take away what negative 5 and 3/8 would, or just 5 and 3/8 would be equivalent to, which would be 43/8. Okay, do I have a common denominator? Yeah, I do. So now I can multiply. Negative 35 is being broken up 8 times. 43 is being broken up 8 times. So let's just figure out in total what our difference is here in terms of what's going to be divided by 8. Right? So negative 35 minus another 43. And in my head, that's what? Negative 78/8. Okay, and there's my answer. Okay, it feels wrong. I feel like I probably made a mistake in there. So we'll look in a second here. But I know that this actually can be reduced because these are both even numbers. Even numbers are both divisible by what? Both divisible by 4. So I get negative 39/4. And now I will box my answer, but I'll also cross my fingers and hope I got it right. Well, they changed it. They changed it to to a mixed number. So maybe I'll do that real quick here too. And I'm going to get it right, okay? Yes, because how do I change this to a mixed number? Well, 4 goes into 39. Well, we'll go into it 9 times. Okay, 9 times because 4 times 9 is 36. And then I'd have a remainder of 3. Okay, so this would be negative 9 would bring us to 36. But then I'd still have 3. Oh, I don't have enough space here. This equals, I'm talking about this right here, negative 9 would be what's equivalent to negative 9? Well, negative 36/36. But I need to get to, negative 36/4. I need to get negative 39. So that's another 3/4 on top of that. Okay? So negative 9 3/4 is the way I write in mixed number form the improper fraction negative 39/4. Yes, we got it here. Okay, let's keep going. All right, this is a little bit easier here. Okay? This is a little bit easier here because this is multiplication. So when it's multiplication, okay, so finding common denominator is really only for adding or subtracting. Okay, only for adding and subtracting here. Here, I don't need to find a common denominator, but what I'm going to do, I'm still going to convert to an improper fraction. So let's do it. Okay, 10. How can I write 10 if it's 10? If it's something over 4, what would 10 be? Something over 4? Well, 40, right? 40/4 here. I can show the workout here if I want to do it here. 10 times by 4/4 is going to be the way I can change 10 to an improper fraction because I'm just multiplying it by 1. Okay, 10 times by 4 is 40/4. Okay, but it's beyond that. I got more than that. I got 10 3/4. So that's going to be 43. over 4. Okay, so that's how I can change this to an improper fraction. Okay, parentheses, that means multiply. Nice. I don't need to find a common denominator. That's nice. I just need to convert this. Okay, -8. How do I change that to an improper fraction with a 9 denominator? I just multiply it by 9 over 9. That's multiplying by 1. That keeps it the same. Okay, -8 times by 9 is -72 over 9. I think we've done that already. But we need to go 4 beyond that. So we're at -76 over 9. Okay, right here. There you have the 4, -72. Go beyond that, -76. Go 4 beyond that. Okay, we got that. All right, so multiplication rules involving fractions. Okay, right? This is why middle school teacher. Hopefully, I had you practicing fractions a whole bunch because there's a lot to kind of keep track of, and just practice made perfect, right? So, anyways, for multiplication rules with fractions, the rules were you multiply the numerators together and you multiply the denominators together. That's all you got to do. All you got to do. You don't have to find a common denominator. Just multiply the numerators together, multiply the denominators together, and then you're good to go. So we do this here, 43 times by -76. Okay, I get a big old number here. I get, -3.268. And I get 4 times 9 is a little bit easier. That's 36. Okay, let's see. Does that actually divide in perfectly? It doesn't. It doesn't. So I'm going to try to reduce this a little bit here. Let's see here. 3.268, make a negative. Let's see if 4 goes into that. Okay, it does. Okay, so maybe what I'll do, let's see if, well, this is an odd number here. So that might be as good as we can go. So 4, if I want to reduce this fraction, I'm going to divide the top by 4, divide the bottom by 4. 36 divided by 4, that's 9. Okay, -3.268 divided by 4. I already did that in my calculator. That's -817. Okay, and yeah, I don't think that reduces at all. Let's see if this is divisible by 3. It's not. Okay, so I think that's the best we can do. And let's check on my, let's see, -90 and 7/9. Well, let's check here. 9, yeah, 9 would go into it about 90 times. Yeah, 81, right? 81 would be 9 times 9. So this would go in 90 times would bring me at 810. And then I'd had 7 left over. Okay, so yeah, if I were to do the work to convert this to a mixed number, I would take 9 and multiply it by 90. Will get you to 810. I need to get 817 though. Okay, so 9 doesn't go into 7. It's 7 too small. This is just going to be negative. Well, I did what? I multiplied by 90, so -90 and 7/9. And that's what we have. Read them and weep. Yes! We got the answer right. All right, last one here. Fractions. You like this? Hey, we didn't even talk about the memes so far yet. Show how well I know fractions. I only did half my homework. That's the spirit. Yeah, that's the spirit. Half, get it? Half is a fraction. Yes, it is. So anyways, we don't like fraction word problems like that. Do the fraction problems. Come on. Fractions, I love oh, look, it's a decimal. Yep, you guys are goldfish here. You just find the gold decimals, you just go for it. Come on. Fractions are beautiful. Actually, fractions are actually the things I like the most. Because I'm a sick person. In 5th grade, I was like, whoa, this math thing's for me. Because I like this. I like to get cutting up numbers. Anyways, let's check it out here. -8 3/4. Okay, we do the same thing. Create an improper fraction. Okay, let's do it here. -8 times by 4, well, that's 32. Okay, so -32 over 4, that'd be -8. -32, take away 3 more, -35 over 4. You see how I did that? Think about it for a second. You can do that in your head, maybe, potentially. -8 is just the same thing as -32 over 4. Got to go 3 beyond that, -35. Okay, divided by, oh, nice. This is divided by, so I don't have to worry about finding a common denominator. That's only for adding or subtracting things that are being divided in the common denominator by the same thing. Okay. So, anyways, this we just multiply the numerators, multiply the denominators. We're done. A little bit different for division here. You remember division rules? Remember that? Keep, change, flip. Great YouTube video. Just search that. Search fractions, keep, change, flip. Great video for this situation. Okay. So divided by -5 over 7. Okay, when you're dividing fractions, you remember what you do? You keep, you change, and you flip. That's what you do. Does that jog your memory a little bit? Okay, let's check it out here. I'm going to keep this. -35 over 4. When I have a dividing by fractions, what do I do to that sign? It actually magically becomes what? Becomes multiplication. My goodness. Okay, well, what's the rule? And you just kind of follow this rule. You can prove it. I can talk through why this is the case, but you don't want to stick on. You don't want this video any longer than it is. Okay, I'm going to change this. So when you're dividing by fractions, you change to multiplication, but what do you got to do? Well, multiplication is the opposite of division. So what you do is you change the opposite of this fraction, right? This is what this is divided by. Well, you're dividing twice by 7, and that's equivalent to multiplying by 7 once because you're dividing twice. The two divisions cancel, it becomes multiplication. Anyways, this is the idea. Yeah, flip. So now we're not dividing by 7, we're multiplying by 7, and we're not multiplying by 5, we're dividing by 5 because dividing by, well, this is the numerator. That's the same thing as multiplying by something in the denominator. Anyways, it can be explained a different time. That's why you always pay attention in math class because you pick stuff up over the years. All right, now we got our answers here. What do? Numerators multiply to one another. Whoop! Denominators multiply to one another. We can get on our merry way. I can get done with this video. I get back to family life right here. We got here 35 times by 7. They're both negative, so I won't put that in my calculator because I know my result is going to be positive. Negative times negative is positive. I get 245, okay? And this is two numbers here. We just ignore the signs. That's 20 over 20. Good. I know that 5 goes into both of these. 5 would go into 200. Let's see if I can do that in my head. No, I don't want to do that in my head. 245 divided by 5. It would be easy enough to do in my head. I think 49. 5 goes into 24 times. So I got 49 over 4. The answer key has been shown. Mixed numbers as your answers. So this is a little bit easier to do in your head here. 49 over 4. Well, you think how many times would 4 go into 49? Well, 4 would go into 48 12 times, and then you'd have 1 left over. So I got 12 and a quarter. I had 12 and 1/4. Is that the answer? Let's check it out. Yes, it's the answer. We did it. Hooray, we did it. Drop the pencil. Okay, all right. Good luck on this, guys. We've got a lot of this for homework reasons. Hope you got the bottom of this without this video. But if not, you watch the video, you're in a little bit better shape now. Thanks for watching. Take care, guys. Bye.